Here we have a step-up air core transformer. That 12-pound coil is being used as the primary. I think it takes about a 1/4 amp. And the secondary down here is a large 75-pound inductor. These are tuned resonant circuits, supposedly. Although the mutual induction shows that they don't even need to be tuned like that. But the main point of the matter is the discharge. Here comes the cattage. The discharge that we obtain. Kitty, get out of there. Get, Skit! Get. You're going to get electrocuted. Get out of there. Well, the point of the matter is here we have to focus in on that discharge. There we go. The camera will see something different than what we actually see. Let's see if we can focus on the discharge itself a little better. Come on, kitty, get out of there. Get, Skit! Okay, now it's not even working right. We'll just wait for it to get steady state again. Oh, yeah, we're ballasting that through a magnet. This is not working out. Get, Skit! Let's go turn the voltage up here. Have to walk across the front. There we are. We're at firing voltage now. Let's try that. About 30 milliamps collapse on the large induction coil. Back on the camera view in here, I'm looking at it. Supposedly at this time period, there we are. See, the discharge completely went out. The frequency that goes in is different from the frequency that goes out. And that's why this happens. And by observing one complete cycle of fullest discharge and zero discharge, right there we just seen, we can compute the amount of time distortion happening, assuming a 60 Hertz frequency. Thank you. How do you end it here? Stop.